Chapter 7.4 is a review in simplifying and adding and subtracting fractions. So first let's simplify fractions. A fraction is in simplest form when its numerator and denominator have no common factor besides 1. So example 1, we're going to write the fraction in simplest form. So we kind of practiced this the other day in class. And so what we want to do is to factor to prime. So here we have 18, and so we can do 3 times 6, and then 24 is 4 times 6. And so at this point, we could probably cancel out the 6's, but let's go ahead and factor to prime just to do this method here. 3 times 2 times 3 over 2 times 2 times 2 times 3. And then we can divide out the common factors here, the common values, so we can cancel out the 3 and the 2, which was that 6 that we saw earlier. And so now we're left with 3 over 4. And here are a couple more to try out. So 18, and let me just try one more with you. 18 is 9 times 2, and 27 is 9 times 3. Now we could go ahead and stop, right? If we have 9, we can cancel that out, and then so it simplifies to 2 over 3. So here's some more for you to finish up and try out. Let's go ahead and do adding and subtracting fractions with like denominators. To add or subtract fractions with like denominators, you're going to write the sum or difference of the numerators over the denominator. So here is the example. If you have a plus b and they're both over c, then you could rewrite it under one bar. And then so it's a plus b over c, and then with subtraction you could do the same exact thing. If you have a over c minus b over c, we could rewrite it in this form. It's most helpful, especially if you have something like number 7, for example, and you can't really add them together, but we could write them over the same fraction bar. So number 1, when we have like fractions, we can go ahead and add or subtract them as they are. So for number 1, we just add the numerators together because we have a common denominator. So let's write it how they did over here. So 7 plus 1 over 12. So that's 8 over 12. And then we need to simplify like we did above. And so this we can factor to 4 times 2 over 4 times 3. And then this simplifies to 2 over 3. Number 2, we have 7 minus 2, and they're both over 9, so let's write that like that. 7 minus 2 over 9. 7 minus 2 is 5 over 9, and we can't simplify more than that. So here are a couple more for you to try and finish out. Let me go ahead and how about with number 7 and number 8? Those are a little more complicated. They're more so what we're going to take a look at in this chapter. So here, notice that we cannot add 4 and minus x squared. They're not the same terms, but we can write it over the same fraction bar. So we can rewrite this as 4 minus x squared over 2 minus x. Now something that you can notice about 4 minus x squared is that is factorable. That's a difference of 2 squares. So remember, I can square at the front and square at the back, and it factors 2. Square root of 4 is 2. Square root of x squared is x, and since it's subtracting, we have an opposite sign. Then that's all over 2 minus x. So then, now we can cancel out our 2 minus x, and so this simplifies all the way to 2 plus x. Now remember, we have to mention our restriction. This disappears, and so we know, or looking at the original, that what can x not equal? X cannot make the denominator 0, and so therefore x cannot equal a positive 2. So remember, you can use your product property. 2 minus x equals 0. Let's go ahead and add x to both sides. And so I hope you see that 2 makes x 0, right? If you plug in 2 here, you get the denominator of 0, and that's not okay. So this is simplified. Number 8. So we're going to go ahead and combine like terms here. So let's go ahead and subtract z minus 4 minus 5z plus 2. I'm going to put parentheses here to remind us about that. So this is z minus 4 minus 5z plus 2 over 2z plus 3. And so with this one, you have to, because we're subtracting, we have to distribute that negative in there. So we're really looking at z minus 4 minus 5z minus 2 all over 2z plus 3. And now let's combine like terms. So we have negative 4 and negative 2, and then we have z and minus 5z. So first z and minus 5z, that is negative 4z, and then minus 4 minus 2, that is a minus 6, and that's all over 2z plus 3. Now looking at the numerator, we have a GCF here, so we can divide out a negative 2. So let me write that over here. I'm going to take the GCF out just so we can see it. Divided by negative 2. The reason why I wanted to divide by negative 2 is I see that's very close to our denominator here. So we have, we factor out a negative 2. We're left with z plus 3. Then our denominator here is 2z plus 3. Oh, and I forgot my 2 up here. And so notice that once I did that, I can actually cancel out my 2z plus 3. And so the final answer here is just this negative 2. And of course, our restriction here, our excluded value, let's take a look at that. This is 2z plus 3 cannot equal 0. So let's solve for what makes it 0. And so subtract 3 on both sides. And so we get 2z equals negative 3 divided by 2. So z equals negative 3 halves. That's what makes it 0 in the denominator. Therefore, that is our restriction. X cannot equal negative 3 halves. And so this is our final simplified answer.